All right, we are recording now. Thank you for reminding me, Fab. I always forget that. Okay, so you're all here for a free webinar called Choosing a Framework, and it's all about how to pick the right framework to meet your specific needs. My name is Sam Taggart. I own a small company in Denver called System Automation Solutions. So this is a little bit about me. Originally, I wrote this presentation so other people could give it. So I normally talk about myself in the third person. I just haven't went back and changed the slide. I started using LabVIEW at a place called Westinghouse Nuclear in Pittsburgh, building testing products for nuclear power plants. And I did that for quite a few years. And then I moved out to Colorado and started my own company. And we work with small teams and help them improve their software development processes. Also, somewhere along the way, I taught a few classes at Colorado School of Mines, and I picked up a bunch of designations. I'm a certified LabVIEW architect, professional instructor, and a LabVIEW champion as well. You didn't come here to hear me talk about myself. So what it all really boils down to is this statement right here: simply making it work is not good enough. And this is a lesson that I learned very early in my LabVIEW career. When I started at Westinghouse, I inherited this circuit board tester. That was the first project I worked on. And it was very impressive. It was a huge rack full of instruments. And it had interchangeable fixtures, and you could put different types of circuit boards in it. It had a 3D probe. And I was like, wow, this is really awesome. And then I got the task of maintaining it, and it was written in LabVIEW. And I went to the LabVIEW Core 1 class, and I learned all the things you're not supposed to do, right? Don't use global variables, don't use these big stack sequence structures, don't use local variables everywhere, obey data flow, all that stuff. And so then my boss asked me to make a tiny change to this program, and I opened it up, and the main frame was a sequence structure stacked 17 frames deep, and there were global and local variables everywhere, and it was a big mess. And yet, that code actually worked. The tester worked, and everybody had no problem with it. But behind the scenes, it was really a house of cards. And that taught me that, the end product of what we see is really just the tip of the iceberg. You really want to have a good, solid foundation. And really, the goal is not just to write code that works, but to write code that also is reliable and maintainable. And those are kind of my two keywords that I chose, because working in the nuclear industry, right, we would put stuff in nuclear power plants. Hold on. Let me switch and see if this gets any better. Hello. Is that better? That looks like it should be better. Vinay, is that any better? Perfect. Okay, so if you couldn't hear me, I was talking about how I started at Westinghouse, and I inherited this project that was a circuit board tester. It looked good on the outside, and on the inside, it was a house of cards. And they're probably still using that circuit board tester today, but I don't think they've made any changes to it because everybody was afraid to make a single change to it because it was kind of like a house of cards. And so the goal is to write code that's reliable, maintainable. And I chose those two keywords because working in the nuclear industry, everything has a really long life of like 20 plus years. Especially if you install stuff inside containment, you go in there like a couple times a year and that's it. So you don't want to be going in and having to maintain stuff frequently. You don't want stuff breaking. So that's why I chose reliable and maintainable. And hopefully you guys are here because you want to do the same thing. Right? Let's do the next slide. All right, so here's the agenda for today. This is what we're going to talk about. I should mention, if you have any questions, just throw them in the chat box, and I will try to answer them. I'm trying to monitor the chat box as we go along. So, all right, so we're going to talk about what is a framework, why do I care, why do I want to use one. Then we'll talk about how to evaluate and compare them. So when we do that, we'll come up with a list of categories and things that we should consider. Then we'll do a very brief description of two of the most popular ones. So AF, if you don't know, is the Actor Framework. And DQMH is a DQMH-Queued message handler. Out of all the frameworks that are out there, those are two of the most popular ones. And then we'll take those two after we've gotten a really brief overview, and they're really hard to go over in just a few slides. Then we'll look at how do they fit into the different categories of things that we should think about. Any questions? All right, so here's a list of choices for frameworks, and it's big and it's long, and they've all got these little acronyms. Actor Framework, DQMH. DCAF is a big one that NI is pushing. Dr. Powell made sure to tell me that I should include his messenger library, which I've left out of the previous version. So there is the state machine object, something called Aloha, a couple of our baseline, and there's several other ones there at the bottom. So if you're just starting out live, you might see this list and you might say, well, hey, where do I start? Right? And so that's kind of what this presentation is hoping to address. So here's a disclaimer. I am biased. Out of that whole list, I've really only played around with the other ones. The ones I've used extensively are the DQMH and the Actor Framework. Okay, so I'm one of Fabiola's DQMH trusted advisors. And I also have done enough work with the Actor Framework that I've written some tools that maybe we'll talk about a little bit as part of this presentation. All right? But just because I haven't used the other ones and haven't really investigated them, that doesn't mean you should. The one that I think you should really investigate that I am planning on investigating more is DCAF. I think that looks really promising for real-time systems. If you do a lot of real-time stuff, you should highly consider DCAF. And also Dr. Powell's stuff, because Dr. Powell's just really brilliant. So, all right. So, what is a framework? When we throw this term around, what do we mean? It's really a software abstraction layer. So, it's a piece of software, so something written in LabVIEW, and it provides a blueprint for how we structure a program. And then we get to customize parts of the blueprint in order to solve our specific problem. And then the framework puts all the glue that holds everything together, and it has some tools and some APIs and things that we can use to kind of pull all the pieces together, right? So the framework, if you look at the picture on the right-hand side of the screen, right, the framework is this steel frame that goes up, right? That's the generic blueprint for how the building's going to look from the outside. But inside, every floor on there and every room can be customized. It could be a doctor's office, a dentist's office, a supermarket, it could be anything, an office, whatever you want it to be, right? You get to customize every floor, but the framework is the overarching thing that's there that defines the structure. And if you look up the word framework on Wikipedia, you'll see there's really three key points. One is inversion of control, which I call the Hollywood principle. Hey, I see AJ there. That's awesome. Cool. All right, so inversion of control, right? The Hollywood principle. Don't call us, we'll call you, right? So you write these codes, these modules, and the framework calls your modules. It calls the code that executes when this particular thing happens, right? You don't call into the framework. It's the main process that's running, and it's what calls your code. As opposed to if you have like a DAC driver or something, you write the main program code and you call into the DAC driver. Now it's kind of flipped. And then the framework also provides extensibility and customization. So you can extend parts of it, you can add things onto it, and you can customize bits and pieces of it. But it also provides some rules, some restrictions, right? So there's some non-modifiable framework elements. There are certain things that you can't change. Generally, like the way messages are sent or certain other things that you just can't change. And that might seem like a bad thing at first, but those restrictions let the framework make certain guarantees that like your errors will always get handled, or like it will always shut down and not hang, right? So those restrictions actually help you, even though, we want to be free and do whatever the heck we want. Having some rules in place really helps us. Any questions? Actually, before we go, I should go back. Has anybody used any of these frameworks? If you have, just throw it in the chat. I'm kind of curious to see if people have actually used or played around with. And I know Luis, I believe, last time asked about learning more about state machine objects. I don't know much about state machine objects. So AJ, if you want to chime in at some point, we hit something, you're like, oh, well, state machine objects does something differently or whatever. Please feel free. I'm sure Luis would appreciate it. All right. So continuing on with our definition of a framework, right? So people throw around the terms design pattern and framework, and they're not exactly the same, right? The design pattern is closer to like an algorithm. In this example, design pattern might be how we put a couple Legos together to build a corner or an arch or a doorway or a window. And then the framework is how we put all those design patterns together to make a building. Okay? So the design patterns are kind of like the building blocks of our framework. And if you look at all the frameworks, you will see that they're all built on all these design patterns. In fact, recently I did a blog post where I talked about, I read the book, The Gang of Four book on design patterns, and I looked at how the Actor Framework uses those as its building blocks. So there's a series, I think there's a blog post about that. All right. So in conclusion, right? Framework provides a way to break down the problem. So it's kind of a methodology, a way of thinking about the problem. For example, in the Actor Framework, you tend to break things into asynchronous processes and think about how they message each other. It provides some basic rules, some things to do and do. And again, those rules that tell us how to do things are actually for a very good reason because they let the framework make certain guarantees. And then they provide tools and support code, flow control, right? You don't have to worry about when stuff gets called. You just say, hey, when this message gets sent, this is what I want to do. And at the bottom, I have the guarantees there that makes. And all you, the developer, have is the customization for your particular problem. The framework says, oh, here, you say, hey, these are the modules I need. The framework handles launching them. It handles setting up all the piping so they can communicate with each other. And then you just specify, okay, well, this takes them this message to that one, and when that gets that message, this is what it does. But all the glue code is already done. So which brings us to why should I use a framework? Okay. Well, it gives you a starting point. Right? You don't have this blank diagram syndrome. You know, like as soon as you see the problem, you start thinking, okay, well, I've got this module and this module and this module and this module, and this is how they communicate. And you don't have to write all that plumbing code. So you're writing less code. And in addition, a lot of the frameworks, a lot of the sending messages and stuff is very repetitive. So they have tools and scripting code to do that for you. So you're writing a lot less code there too. You don't have to write the code to put the message in the queue and DQ it and all that. That's already written. Provide structure, right? So if you write several programs in the same framework, they'll look somewhat similar, which helps you to standardize. Support. So the standardization helps you support each other within your group, but also all these frameworks have user groups and communities, and so you can get outside support. Some of them have more than others. Talk about that. You can avoid some common pitfalls. Pitfalls might be like stop messages that never arrive and stuff hangs, losing error messages, right? A lot of homebrew frameworks that people come up with on their own sometimes miss those points or don't get them quite right. These frameworks that we're talking about have all been tested, and definitely the Actor Framework, DQMH, and DTAF, I know all have unit tests written for them. I wouldn't be surprised if most of the other ones do as well. So they're definitely tested, and they've been used by lots of people in some very big projects. All right. So, well, you might be sitting there and thinking, well, I'm really smart. I know what I'm doing. I can make my own framework. And I wouldn't say don't do it, but I would caution against it. You're reinventing the wheel. So, if one of the existing frameworks will do what you want it to do, I would say it's a waste of energy to create one just to say it's your own. But that's just me. But also, again, avoiding the anti-patterns or pitfalls. But if you're really going to do that, the first thing I'd say is consider why you want to build your own. Is it just an ego thing, like I want my own framework? Or is it, hey, these frameworks, don't do exactly what I need them to do. How can I make them do what I want them to do? And if you fall in that boat, I would say take an existing framework and modify it or build on it. A great example of that is something called the MVA framework. Ethan Stern, I think, is a big one pushing that. With him and John McBee and those guys out in Boston. Have this framework that sits on top of the Actor Framework. So all the modules inside it are actors, but they have this mediator boss that they do these publish data to, and everything else subscribes to it. And it's really cool looking. You should check out, Ethan did a presentation at one of the CLA summits recently, or maybe even in NI week, I don't remember, but look it up. There's a presentation or two out there. It looks really cool. If you like Actor Framework. The problem is you kind of have to understand the Actor Framework first before you can use that. But that's a really good example of somebody taking an existing framework and modifying it. All right, so that's our basics on frameworks, what they are, why we've used them, why not reinvent your own. And now we're going to talk about the criteria, right? How do we compare all these different frameworks that are out there? So the first thing is don't stick a square peg in a round hole. Right? So when you're looking at the frameworks, they're very specific things. As an example, the ones that I'm really familiar with, DQMH, its design idea is to be easy to debug. Actor Framework, its design idea is to be super flexible and take advantage of all the object-oriented dynamic dispatching. DCAST is designed to run very deterministic real-time programs, right? So, if you're not doing real-time programming and you don't need determinism, DCAST is probably not the right choice. All right, so that's like the first thing. Is just look at the general paradigm. Think about, modules, right? How many modules is designed to handle a large number or a small number? How do the things communicate? Is it synchronous, asynchronous? Single-threaded, multi-threaded? There's all these questions. It's designed to run on RT and FPGA or not. And so by looking at those, you can pretty quickly rule out some of the frameworks and say, well, this one's designed for this specialty thing over here, and I don't use that at all, so that's probably not the one I want. So that's just the first thing. The next thing I look at is power and flexibility. And the previous version slides had power, but I kind of put them both up there. So power is like how deep you can go in a particular area, right? The complexity of the problem that you can solve. Flexibility is the variety of problems that you can solve. And generally, there's some trade-off there, right? You go really deep in this one specific area, but then it becomes so narrow that you can't handle problems outside of that area. But the key here is that the power and flexibility needs to be appropriate to the problem at hand, right? So if you look at these two cars, right, one's a Ferrari, a Lamborghini, or something, the other one's a Volkswagen, which I think that's what that is. And so if you want to get from point A to point B as fast as possible, and that's all you cared about, you would pick the Ferrari sports car. But now if you say, well, okay, I live somewhere where it snows, in the winter, I want to be able to get around in the winter, the sports car doesn't look like such a good idea anymore, right? Well, if you live in Hawaii, do you really care how well it gets around the snow? Probably not, right? And then, sometimes you can have more power than you need, and sometimes that's actually a bad thing, right? So, probably nobody here would get their 16-year-old the Ferrari to drive to school in, right? So it's way more than he needs it. He doesn't know how to handle it, and he's getting nice. So picking a framework that's super powerful but really complex and hard to manage for your first project and give it to some junior developer, probably not a great idea. So this is just one other aspect to think about. And, often that power comes at and the flexibility, both of those come at the cost of complexity, right? The more powerful something is and the more flexible it is, right? When you have that flexibility, now you've got all these choices, and now you end up with really a lot of complexity. And so, which one of these two things would you like to debug, right? The old school mousetrap on the left, it's pretty simple. It's a spring. It either works or it doesn't. The Rube Goldberg looking thing on the right, any number of things could go wrong there, and you have to figure out which one.
right? So I'm a big fan of the KISS principle. Keep it simple, stupid. So, simple in my mind, if it does the job, always wins. So the other thing to think about with all the complexity is if it's really complex, it's going to take some time to learn. And so I'm going to use an analogy here, and it may not make sense to some of you guys, but it totally makes sense to me. If you've ever been in this situation, I'm sure it will make sense. I live in Colorado, and skiing and snowboarding are really huge here, and I've done both. And I don't know why, but if you strap skis on somebody and put them at the top of the hill and push them down, and it's a bunny hill, generally people tend to make it. It's not all the way down, most of the way down, right? For whatever reason, facing down the hill, sliding, our balance, it works well that way. Everything works fine. You can get to the bottom of the hill, right? Within a day, they're off, graduate from the bunny hill, and they're off doing something else. Put somebody on a snowboard at the top of the bunny hill, and you send them down, and they go 5 feet and fall over. And they get up and go 5 feet and fall over. They just keep doing that, right? So the learning curve is very different. But yet, in a month, those two people are equal with each other, and pretty quickly the snowboarder starts to take off, right? Snowboarding has this, I call it like an inflection point, where you don't get it, and all of a sudden you have this aha moment. And then all of a sudden it makes sense, and then you can go pretty much anywhere, versus skiing is kind of like a slower, more gradual learning curve, and eventually it tops out. So how does this apply to picking a framework? Well, the key question you got to ask yourself is, do I have the time to take the time to learn about how to use the framework? Or do I need something where I need to get up and running right away? Right? If you've got the time to learn about the framework, it may be worthwhile to pick a more complex framework because it's going to pay off in the end, and that you're going to be able to tackle more complicated problems later. But if you need something that works right now, then maybe you want a simpler one that's a little bit easier to get started with. And that leads us into competency, right? So it's not just about learning curve, but it's also about competency. And we're all adults. Hopefully, we're all self-aware and we know where we are on the learning curve in LabVIEW. But you got to judge not just yourself, but also the other people on your team that are going to have to work on this project that you're going to have to work with and share it with. And then you've also got to think about who's maintaining the software, right? The person who comes along next, or who you're passing it off to, and potentially your customer, right? So if your customer, doesn't know a lot about object-oriented programming LabVIEW, and you give them some big object-oriented framework and say, here's your software, go run with it, they're not going to be able to maintain it. So that is something to think about. And then we come to tooling, and this is a huge differentiator in frameworks, and this is probably, I would say, the number one reason not to write your own framework. Because writing the tooling takes time, and it's a pain. And Fabiola will surely attest to this if she's still here. It looks like she took off. But anyway, you can ask Fabiola about it in a week if you happen to go there and see her or talk to her. But basically, it's a lot of work to write all the tooling, but it saves you a ton of time. So a framework without tooling is pretty useless, right? So there's going to be all these repetitive actions that you have to take, and you really, really want to be able to use power tools on and not have to sit there with a wrench turning it up for 20 minutes to take it off, right? You generally work on cars, you know what those tools are, you know what the difference is. If you haven't, then sorry, I like working on cars. So, all right. So, when you're doing that, when you're working on stuff and working on cars and stuff, you got to debug things. And so, what kind of debugging tools are available? What kind of support is available, right? Especially if you're super high level, maybe you don't need a lot of debugging and support. Maybe you can figure it out on your own. But if you're going to hand this off to the junior developers, you want a toolkit that has a lot of debugging and support built in, because you don't want them running to you every 10 seconds, right? You want them to be able to search on the forums and find information, okay? So that's something you got to think about. Are there debugging tools built in? How easy is it to debug? And where can I go to get support? And some of these toolkits, some of the ones on Lava are just thrown out there and hey, use it if you want. Some of the ones like Actor Framework, DQMH, probably State Machine Objects too, have a huge knowledge base and user base, and you can get blessing. So those are all our categories. We'll review those before we do our comparison at the end. So now we're at the build third. We're going to review the Actor Framework and the DQMH really quickly. So hopefully everyone is at least somewhat familiar with them, maybe seen them before. Sometimes I do a demo. I'm not going to do a demo. I'm just going to look through some slides. So the first thing to say about all this, and I think I just said it, but I'll repeat it, we're just touching the tip of the iceberg. There's a lot to learn about all these frameworks. There's a whole lot of things going on behind the scenes that you don't see. We're just going to look at real quickly the important things that you see for how you interact with it as a developer and how it works. And we're going to look right at the core, and then we're going to move on. Mostly because we don't have time. So AF is the Actor Framework, right? So when you start talking about the Actor Framework, the first thing you got to do is take a step back and understand the theory behind the Actor model. The Actor Framework is based on this thing called the Actor model. And if you don't understand that, then the actors is probably not going to make a lot of sense. All right. So what is an actor? An actor is its own parallel thread. So it's off doing its own thing. It has its own state data. And it's autonomous, right? So it's got an actor that calls it, but it makes its own decisions. It decides what I want to do. And you don't tell it what to do, but you make requests. You say, hey, go do this. And the actor can decide, you know what, I'm not in a state where I can do this. Forget you, I'm not doing it, or they'll go do it. And there's not really this synchronous of like, oh, go do this and then come back, right? It's all kind of asynchronous. And the only way to communicate with an actor is through messages. So every actor has a mailbox, right? And in the Actor Framework, right, each actor has the mailbox of its caller, the process that launched it, has its own mailbox that can talk to itself, and any other actors that it launches. And we'll look at that in a minute. And everything's asynchronous. Okay? So the first big paradigm shift when you start talking Actor Framework is start to think about asynchronous processes running on their own, breaking things off and saying this is off here, running on its own. And I don't have any access to it except for messages in and out. So that's one of the rules, right? No backdoor communication, just the messages in and out. All right, so this is really the core of all of Actor Framework. If you look closely at this VI, ignore the stuff on the left for a second and just look at the VI itself, the block diagram. It looks shockingly like a queued message handler. All right, so you notice we've got an actor in, and that goes into a shift register, so that's our state data. So actor in would contain all the data we need for our actor to do anything. And then our actor also has the send to self and queuer. So this is its mailbox. And it is the first VI there, the one with the yellow header. It's DQing a message. So in the loop, the first thing it does is it sits there, waits, and says, oh, I got a message. DQs a message. And then the VI in the middle is a do VI. And so that does whatever that message is supposed to do. So it does some calculations, updates some state data, maybe sends some messages somewhere else. And you'll notice that has an actor in and an actor out. So that has access to the actor's state data. And after we do the message, then we check to see if there are any errors. And we decide if it's time to stop. If we don't stop, we just loop around and do it again. And then on the far right, we have a placeholder there, the stop VI, that at the very end, before it exits VI, we call the stop VI. And we do any kind of cleanup or anything we need there. That all comes with Actor Core, right? So that comes with the Actor Framework. You don't have to write that. That's already written. It's in actor.lv-lib Actor Core, right? Somewhere hidden down in there. And since the Actor Framework ships the library, you already have that on your computer. Now on the left, we're looking at an inheritance structure. So we've got an actor, which is just a generic actor. And then we have a time loop that inherits from that. And then more specifically, we have a level controller, and then we have a cooler. And we'll look at what happens as we move down the hierarchy. So, right, that Actor Framework is useful. That Actor Core, right, processes messages, but maybe I want to do a little bit more. So I create a time loop controller that inherits from actor, and I override actor core. And I add this code at the bottom here that says, hey, every so many seconds, send myself a message and tell myself to update. Right? So you can see it's reading the self in queuer, which is its own mailbox, and it's sending a message called send update. That's what the while loop at the bottom is doing. And it's calling the parent method. So that call parent method is exactly as if all of that message handling code had gotten dropped right on this block diagram. Right? So as this loop that you see is sending updates, the other loop is sitting there processing. And then we jump down, so level controller doesn't override that actor core at all, but what it does add is it adds, if you look at one of the first things that happens at the top line as VIs there, is it adds a deadband, a low and a high value for the deadband. Right? And then in our cooler, we're overriding actor core, and if you look all the way on the right before it exits there, we're calling the parent node. So it's calling the time loop. So it's as if that entire time loop structure, right, is dropped there, and the parents is also dropped there. So we've got the message handling loop, we've got the timer spitting out update messages, and then we've got all this stuff going on as well. In this case, it's launching a bunch of nested actors. And we'll talk about exactly what a nested actor is, but basically the cooler is saying, hey, I can't do all this myself. I need some other actors to help me. And so it's spawning those processes off. Right? And that's what the launch nested actor VI is doing. And you can see that it's setting some settings before it does that. It passes the dual fan, the dual control, and the water level into the launch nested actor. You can see it gets something back, and that is the mailbox for each of those. So now our cooler actor has access to all those mailboxes, and so it can get a message and do something with that and send out messages to those. Have I lost anybody yet? Actor core is definitely complicated. If you have questions about it, we should probably talk offline. I don't know that we're going to be able to cover all of the actor framework here. And so this is what the do VI looks like. So we've got an actor coming in, we've got our set fill amount message is the message itself, right? So we dynamic dispatched off of that, and this is what we get. And then we're testing to make sure that the actor is our test mix H2O actor. And if it is, then we're calling this set fill amount, which is a method of our test actor. And then some other things that you can override, handle error. You can determine how your actor handles errors. You can override stop core, which is usually you shutdown stuff. So clean up any references, maybe stop any other actors that you launched. And then pre-launch init is where you initialize everything before it runs. So here's some VIs that are on the palette. And so basically, launch root actor, so at the top left, right? We pass an actor, it starts that actor core process running, and it gives us back the incure, which is its mailbox. And then launch nested actor, we pass it the actor that the launch nested actor is to create another actor that's owned by another actor, right? So we have the root actor. If you look at the tree on the right, we have a root actor that we've launched, and it decides, hey, I want to delegate some stuff to some other actors, so it launches actor A and B. And then actor A delegates some more stuff, so it launches A1 and A2, right? So this launch nested actor, we pass in the caller, the actor that's calling it, we pass in the nested actor that we want, and that launches the nested actor and gives us back its mailbox. And it also gives it a copy of the caller's mailbox so that it can send messages back up the tree. And then the stop message there is just to show you that that's how you send a message, right? There's a VI to send the message, you pass it in an incure, and it sends the message to whatever mailbox you give it. And then every actor has two methods called read caller incure and read self incure, and that lets it send messages to its caller or to itself. And the reason you need to send it to yourself is, like, the actor core of the ultimate actor class, or at the top of the hierarchy, is the one that handles the messages. So if you want to put messages in there from elsewhere, you got to have access. And this actor tree at the top right, this kind of shows how the whole launching process and how it works. And this IR should actually be bidirectional. The root actor can communicate with actor A, because when it launched it got back its enqueuer. And actor A, when it was launched, got its caller's enqueuer, which is the root actor. But note that root actor cannot communicate directly with A1 or A2 without doing some passing around of values, because it does not automatically get access to its mailbox. It has access to actor A and actor B, but it doesn't have access to the sub-actors or the nested actors. Hopefully that's clear. All right, now we're going to talk about DQMH. Sorry if we're going fast, but I'm trying to fit all this in. So DQMH is basically this queued message handler, right? Stands for Delcore queued message handler. It's kind of also a mix of producer-consumer. So this would be the equivalent of the actor core VI. This is the VI that runs when you run a DQMH module. All right. And the first thing we do is we register for some events. Right. So the way the DQMH module communicates with the outside world is through events. So something else fires a user event. This DQMH module will pick it up and do something, and it can fire off user events, right, which are broadcasts. It just says, hey, I did something, and anybody out there who's listening can grab that user event. So that's why we have the event handling loop at the top to capture all those events coming in from other places, and also to capture any front panel events. So you click on a button on the front panel, you can capture that user event, and then everything is funneled into this message handling loop at the bottom, which is queue-based, and you can see it's got some shift register data that's passed around. If you replace that with an object, right, and replace that case strictly with dynamic dispatch, it would start to look an awful lot like your Actor Framework stuff, right? So they're similar and related. And one of the best parts about DQMH is you get a test harness for free, which is basically when you create a new module in DQMH, it creates a module for you and also creates this thing called a tester that basically calls your module, and so you can test the API to make sure that it all works. It's interactive. You can go up and press buttons on there and launch your DQMH module and send it messages and get data back. It's really cool. Actor Framework by default does not have that, and it's very hard to test Actor Framework stuff. So if you look up, I'll put it in the chat here. I don't remember the exact URL, but I put out a tool called the AS Tester. If you look it up, it generates this for an actor in the Actor Framework. And I find it very useful. So you look that up. DQMH also generates some user or unit testing stuff to write unit tests as well. So again, the main point of Actor Framework is flexibility, right? Be as flexible as possible with all that dynamic dispatch. The main point of DQMH is to be easily debuggable, hence you get the debugger. So here's a slide. On the left is what you get in the Project Explorer, right? You get a module, my singleton module, got public API, got a bunch of private stuff, and you can see the requests are all VIs. So if you wanted to do something, you don't have to worry about all the complexity of getting the user event ref and firing it off. You just call that VI and it does it for you. That would be the bottom right here. Do something, right? It's pulling the do something event ref out of a functional global variable, and then it's firing it. And then that gets handled in your event handling loop of your main module, which everything I showed you that was in main.vi. So the previous screen, that was on main.vi. And at the top, you have two things there. One is start the module, right? You grab the events that you want to register for, and then the sync module events is just so that you don't miss anything. It'll wait. And it fixes the timing, any timing issues there. And then this broadcast events for registration. Any module can just grab that for any other module and say, hey, I want to register for all its events. And then you have access to all its events. And anytime it does something and generates an event, you'll know about it. And then you can do whatever you want with it. Yeah, so the other really nice thing is everything in the DQMH is type def, which is really nice. If you want to add a piece of data or something, just add to type def. And one thing I didn't mention is in the previous slide, the queue at the bottom is a string invariant queue. Normally I don't like because, I'm more of an enum person, but also I don't, you have typos and stuff, and I also don't like the variants because you got to do all the typecasting, and it's easy to screw that up. A, that's all created by the scripting tool, so you don't have to really worry about that, so that's nice. So it's really hard to get typos. And then B, the variant, the decrypting the variants and stuff, it's all typed as well, so it's really easy. So it's very hard to screw that up. So that is quite nice. So if you create your own, you might not have that. So that's one of the nice things about using what somebody else has done. When we talk about the tools, you're going to see that both of these tools, the Actor Framework and the DQMH, have tremendous tooling involved. All right. And here you have clonable modules. So the last one was a singleton module. So anytime you call anything, there's only ever one copy of it running. Clonables, you can have multiple copies in memory. And then your do something VIs, your message VIs all have a module ID that then decides which module responds to it. And there's a way to send something to every one of your clonable modules that's running, or just one in particular instance. So, all right, that's it for our Actor Framework and DQMH. AJ, you've used the Actor Framework before. How did I do? Did I cover everything, more or less? At least enough? You guys can feel free to ask questions. And also, AJ, when we go through this comparison, feel free to chime in if you want to say anything about sentient objects. I know Luis wants to learn more about it. I'm sure there are probably others. So, all right, so this is my mandatory disclaimer, right? So, all the frameworks there, none are good, none are bad. They all just solve different problems in different ways. And so the trick is to find the one that's right for you. Okay. Well, thank you for letting me know, AJ. Okay. All right, so I'm just trying to show you how to think about the problem and how to pick and choose between them. I'm not necessarily saying you should use the Actor Framework and DQMH. I do think they have some advantages in that they are the most widely used and the most widely supported, but that doesn't necessarily mean that you shouldn't consider the other ones. All right, so just a reminder, these are the things that we talked about, how you should compare them. Just the general paradigm, does it fit what you're trying to do? How powerful versus how flexible it is. That comes at the cost of complexity, right, which affects your learning curve and the competency that you need in order to use it. And then tooling, debugging, and support. Right? Those are all important things to consider. Right? The tooling is going to make you more efficient, maybe help with the competency and learning curve. Debugging, it's inevitable that you're going to run into problems. It's just the nature of software engineering. And then support, right? Sometimes you'll be able to debug it yourself. Sometimes you're going to need to go get it. All right, so here's my general, and I Actor Framework main point is flexibility. Right? That's why it has all the objects, because you can override almost everything. Community, okay, Michael says he would add community. Okay, yeah, so I kind of included that under support, right? The support not just from the people who wrote the toolkit or framework, but also the community. So that's important. And also, too, the larger the community, right? If, for example, you write something in this and you get hit by a bus, your customers of the company can go hire somebody else who knows how to use this framework versus something that's kind of obscure. So that's a good point. Okay. So Actor Framework flexibility, DQMH is all about debugging, right? And being more accessible to people who are not object-oriented fanatics. All right, so general paradigm and how they work, right? Actor Framework, each actor is a queued message handler, right? All the messages are asynchronous. The messaging is kind of hierarchical. I showed you that tree structure, right? Which has some advantages because it's easy to trace stuff. Has some disadvantages in that, if you want to pass data from one leaf on one side of the tree to one leaf on another side of the tree, you got to create a bunch of messages to pass it around. So it can be a problem. Other problem with actors is they're contagious, right? Actors like to send messages to their callers. So if you have one actor that you sending messages to the actor is not a problem, getting data back is a problem because you got this mailbox, but how do I handle that? I don't know if I mentioned that in the presentation. I think I do. I'll have to. But yes, so Cyril asked about DQMH and test stand. That is a very real concern. DQMH is designed to work very well with test stand. Actor Framework is not designed that way by default. If you take the Actor Framework course, it shows you how to put some shims in there to make it work. And it's totally possible to use Actor Framework with test stand. But if your goal is to use test stand and you don't need the flexibility of the Actor Framework, my recommendation would be DQMH or something else. So that got me a little sidetracked, but that's good. The best part of all these presentations is the discussion, right? So you guys can look at these slides any day on your own, and but the discussion really brings out a lot. So yes. So yeah, when we get to support stuff, Michael, Fab has a wonderful website with all kinds of support stuff and all kinds of examples. I'm pretty sure there are also some examples for Actor Framework doing that as well. But so in the Actor Framework, there's no concept of singletons, right? Whereas DQMH has that. So if you, for some particular reason, really want a singleton, then DQMH might be a consideration. And again, at the bottom, as I probably should put that one at the top, right? Actor Framework is designed for maximum flexibility versus DQMH is designed for approachability, right? And in DQMH, right, NIQMH template, all the modules are asynchronous, although they do have both have some stuff built into them to do call and response messages. I would say it's a little bit better defined and supported in DQMH than in Actor Framework, but it's certainly possible. Events are not hierarchical, right? So there's no tree in DQMH. Everything's a tier, which presents some of its own problems, but also makes certain things easier. DQMH, one of the nice things about DQMH is it plays well with others, and there I mentioned test stand, so it's because Michael or Cyril who mentioned test stand. So yeah, DQMH plays really well with others in that you can drop, since you're just dropping VIs, you can drop them anywhere. Actors, right, when you launch them, you get back to secure, and you got to pass that around everywhere in order to be able to send a message. So you got to figure out how to pass that around or store that so you can access it. And then when you get data back, instead of coming back on events that you can just register for, now they're coming back on this queue, and you've got to DQ them and figure out how to handle that. So totally doable, but just a lot more hoops to jump through. All right, power and flexibility, right? So Actor Framework, it's really easy to dynamically load and run actors. Really easy to do plug-in type architectures for Actor Framework. DQMH, it's really easy to dynamically run modules. Dynamic loading is a little trickier, but doable. So you can replace your data in the shift register at the bottom of your DQMH, your message handler with a class, and then you can dynamically load plugins that way. Yes, that is my one thing I would say about DQMH, right? In Actor Framework, you have a bunch of actors that are really similar, but just slightly different using the inheritance tree. And in DQMH, you can actually do that as well. You just have to use inheritance. Now, the one downside to that is the messagings that you can send are kind of fixed. Now, one thing I would say, something I've been thinking about a lot lately, is when it comes to testing and being able to write unit tests for coding things, it's good to code to an interface, not an implementation. Right? You'll hear text-based programmers talk about that all the time, right? And so, yeah, in your DQMH, you can't create 3 or 4 different modules that are all similar and inherit from this one thing and add extra functionality. You can do that, you just can't add extra messages, which I honestly don't think is a bad thing because it forces you to program to that interface that is the with the DQMH in and out. Hopefully I didn't go off on too much there. So inheritance, right? Actor Framework has inheritance. Really easy to do. DQMH, it's not built in. You can certainly use it. When you get in DQMH inheritance, it's not a bad thing at all, but it's just like part of the reason that DQMH exists is for people who don't like or use objects, right? To lower the barrier to entry. When you start introducing inheritance, then you raise that barrier to entry a little bit, maybe. Actor Framework also can use composition, right? So you can have an actor and it can launch a bunch of sub-actors and delegate stuff to them, and the caller doesn't even know a thing about it, right? You can't really do that in DQMH. You can have one module and you can start another module, but there's no concept of composition built in. So any of those modules that you launch, anything else can send messages to it and interrupt that flow and break that encapsulation. So one technique Fabiola's mentioned for that to me is take your DQMH module or modules and wrap them in a PPL and then just expose the one you want. And that's definitely doable. And then other modules outside can't mess with your sub modules or nested modules. So it's all possible. And then for the Actor Framework, right, when it comes to power flexibility, they've got a bunch of different messaging paradigms, and you can do loose and zero couple messages, which are really nice. The DQMH, in order to get that, you would almost have to have your API wrap the API in a class structure. And you could totally do that. So just depends on how you want to do it. All right, so complexity, right? So if we look on the right, that's DQMH. We've got one module with a whole bunch of VIs under it. And on the left, we've got a library with a bunch of classes, and the classes have VIs, and yeah, all the classes seem rather simple. And it looks like, from this slide, that Actor Framework might be simpler. Until you look at the class hierarchy, which is pretty ridiculous. So the blow up is just the left-hand side that shows the hierarchy of actors inheriting from other actors, right? So you can see at the top, I've got a whole bunch of test actors, and then I've got a set of actors that have a subpanel, and then underneath that, I have some that self-update. And I have some that represent some pumps. And then if you look way off to the right, there's another gigantic hierarchy here, and that is all the abstract messages. So one of my complaints about the Actor Framework is if I have this indexer, well, if I'm looking in the project, I don't really know usually what class it inherits from. So I can send that any messages that it can receive or any messages that parents can receive. So how do I determine what messages that particular indexer can receive? It's not exactly trivial. DQMH, it's all really simple because it can only send or receive the ones that are right there in the module. There is no inheritance to change any of that. So that's a thought. Maybe you're okay with all of that complexity. Maybe you need it. If you don't need it, I would say it's a negative. All right. So what makes the Actor Framework complex? Multiple messaging paradigms, highly coupled, zero coupled, loose coupled. Casey presented something at NIWeek or the CLA Summit last year about double decoupled messages, or I forget what he called them. You can go research that. Casey Lemur's stuff. He might be presenting at NIWeek. I don't really remember. DQMH, two event types. Request, data coming in, broadcast, data going out. Actor Framework messages aren't type safe. So a mailbox is just a mailbox. Mailbox does not know what it's attached to. So I can send any message to any mailbox. And I can send messages to people that they're not intended to. Events, because of the way they're scripted and everything, are very type safe. It's part of the library. If I call that send event VI, I know exactly where it's going. Actor Framework gets the large class hierarchy, partly due to the messaging paradigm and due to the fact that everything inherits on the actor side as well. DQMH hides a lot of its event complexity. with creating and managing it by scripting. Yes, if you're interested in that, send me an email or something, and I will make a post about it or something. Just remind me. I got a lot going on, so I might forget. And Actor Framework, right? It's difficult to locate the message to send, right, because of the large hierarchy. When it comes to DQMH, finding event VIs in the project, super easy. They're in one folder inside your module. That's it. So, learning curve. Actor Framework, I think, is like snowboarding. The first couple times you try it, you have no clue what's going on. And then all of a sudden you have this aha moment, and then you get it, and then it just starts to take off. DQMH, you look at it, and in a few minutes you can figure it out. Seems pretty simple. And you progress, but eventually kind of plateaus a little bit. Competency-wise, right? Actor Framework pretty much have to know OOP and be comfortable with inheritance, geared towards CLA or high-level CLD people. DQMH, out of the box, no OOP needed, geared more towards CLD people. You can gain a lot of the advantages of Actor Framework by adding OOP to the DQMH, right? But then you're upping the complexity again. Tooling, if you played around with either of these, you will know that Actor Framework tooling is all over the place, right? Designed to be managed from the project window. You go to the project, you find your actor, you right-click on it, you get some options. You click on a message, you get other options. You click on a method, you get other options, right? And for some people that works, they like, hey, if I'm on this, I know exactly what I know where I'm going. But it takes a while to learn. That's one of the things that takes a while to learn. DQMH, the tooling is really simple. It's all under the tools menu, DQMH, that's it. And it's very well designed. Another downside to the Actor Framework tooling, it may have gotten fixed, but if you remember at some point, this stuff that's in the project window, because it runs in the background, and it's a project provider, it can really slow down your computer a lot. So if you got a really big Actor Framework project, it used to be that clicking on some of these menus would really slow things down. I think that's been fixed, but if you're using older versions of LabVIEW, that's something to be aware of. All right, we got like 5 minutes. I want to fly through these slides. We might run like a minute or two over. Try not to. So, tooling, right? Both of them provide a template. Both of them include palettes. They both, Actor Framework used to install via VIPM. Now it's already on your computer because it comes with an I. DQMH installs via VIPM, pretty easy. Actor Framework tooling's all over the place, but it's context sensitive. DQMH is consolidated. You've got Actor Creator, Module Creator. Actor Framework does not automatically create this debugger. Again, Google AF Tester or send me an email, and I'll show you how to do that. DQMH automatically creates it. Right, we got the message maker, event creator, they're on par. Actor Framework, renaming, deleting stuff is difficult. Maybe that's changed. I haven't used the most recent version. But it does let you rescript some stuff if the inputs change. DQMH has lots of tools for naming and renaming events, and all your event data is typed-fast, so adding new data is easy. Debugging. Actor tree makes tracing messages easier. Execution trace, by pulling up the block diagram and watching this stuff run along the wires, doesn't really work. Finding the correct clone of Actor Core and other VIs is difficult because everything's cloned, but it does have DETT support built in. Desktop Execution Trace Toolkit. If you haven't used that, it's pretty cool. Totally useful. You can use it in an executable even, which is cool. DQMH, broadcast nature of events makes it tracing the flow of events harder. Oh, well, this thing changed here. Well, what happened? Well, I don't know. Who's registered for it? You gotta go find all the ones who are registered for it and then figure out what's going on. Execution trace is easy. So there's a method in the tester. You can pull up the block diagram. You can watch what's going on. Has a built-in debugger, makes showing the front panel of the block diagram really easy. Does not have DETT support built in. But you can also build the debuggers as part of your executable. Fabiola has some information on that on our website. So you can get a lot of those features. Support. They're both really well supported. Actor Framework officially supported by NI. It's got all this stuff. There's official NI training class. DQMH, no training class, which has got tons of videos and documentation. And there may be a training class at some point in the future. If you're interested in a training class for DQMH, let Fabiola know, because I know she's thinking about that. So if she gets enough people who say, yes, we're interested, she might start one. The one thing DQMH has going is really quick turnaround on bug fixes. Somebody found a bug a few weeks ago, and it was turned around in like a week or a couple days. NI, right, turnaround bug fixes is generally linked to their NI release cycle. Right? If it's really super critical, then you might get them to release a patch sooner, but generally it's tied to their release cycle. All right, so you're saying, okay, well, which framework should I use? Well, the answer is it depends. Here's kind of my flow chart for my decision-making process between the Actor Framework and DQMH. You might have different considerations. Generally, first thing I look at is skill of everybody involved. Right? If they're beginner or intermediates, I don't bother with Actor Framework because I just think it's too complicated and I don't really want to teach them. So I'd rather use DQMH. If everybody's advanced and it's a huge project, I immediately just go to Actor Framework because I feel like it scales a little better. If the project's not ridiculously huge, then I'd go to flexibility or debuggability, right? So if the specs are like required to be really flexible and, you know, I've got a lot of these modules that are really similar but slightly different, I might consider the Actor Framework over DQMH versus if it's something where I know debugging it's going to be a pain, I'm going to pick DQMH. So hopefully that kind of helps you start thinking about the problem. And, you know, if you don't standardize on one framework, or maybe you have two that you use or something, I recommend making some kind of decision tree like this. I think it's useful. So here's your list of choices again. We're almost done. Right, so simply making it work is not good enough, right? Picking a framework, it's just the beginning of all this, right? There's other stuff to consider. I list some stuff there: source code control, unit testing, automated builds, continuous integration, code reviews, right? Reuse code. So if you want to stop and talk about any of that stuff with me, I've got some time. Go to this bit.ly link and set up an appointment. It's not for 2 weeks. The next 2 weeks are kind of busy for me, but after that, I've got some time set aside. Come, we'll sit down for an hour. We'll talk. I'll learn all about what you're doing and whatever problems you have, and hopefully at the end of that, I'll give you some hints and tips and point you in the right direction. And yeah. So if you want to take advantage of that, just go to the link and sign up. And there is a survey. I would really appreciate if you guys could go to the survey and answer it. It shouldn't take you long. It's like 4 or 5 questions. Give me an idea of what you guys are interested in learning about next and what other topics you'd like to talk about, and just make sure that the format works and all that. The next webinar is going to be Wednesday, June 26th at 11 a.m. I haven't completely decided on a topic yet, but I'm thinking unit testing. Talked about JKI, BI tester. I had somebody ask me to put a presentation together for that, so I have the presentation. So I think that's something that I'm going to do. Any questions? Hopefully you all found this very useful. I really appreciate you guys giving me an hour of your time. Again, please feel free to schedule an hour talk. I'd love to talk about you, hear what you're doing. If you need help with any of this stuff, we offer all these services. We do met with local alliance partners and just done design reviews and code reviews and you know, hey, I've got this one problem. I just need a few hours of your time to help me fix it. That's fine. So any of that type of stuff that you're interested in, just let me know. And if you're going to NI Week, I will be there. Come say hi to me at the Lava Barbecue. Buy your Lava Barbecue tickets. If you have not, it's a good time. You will not regret it. So thank you, guys. I really appreciate your time, and I'm going to get going. So have a nice day.